All right, everyone, it is now 1:02, and we are going to go ahead and get started. Thank you so much for joining another installment in our Deeper Dive webinar series. If it is your first time joining us here at Losant for one of our webinars, welcome. And if you are a returning attendee, welcome back. We are grateful for the time and excited to have you all here with us today. Just briefly, before we begin, a few housekeeping items. For your awareness, this webinar is being recorded, and the replay will be made available to you in a couple of different ways. After this webinar, we'll send you an email with the link to the replay. Additionally, this webinar will be made available on Losant's YouTube channel, as well as on our Deeper Dive webpage. As for questions during today's session, throughout this webinar, you'll most likely have questions that you'd like to ask. I would like to point out a couple of key features in the Zoom conference. You can use the Q&A feature or the chat function to post questions, and I will be monitoring these throughout the call. At the end of the presentation, I will moderate a Q&A session with the posted questions with our panelists. And now to introduce today's speakers. Again, my name is Patrick Smith, Digital Marketing Manager here at Losant, and I will be your host today. Also joining us for today's presentation, we have Andrea Ricetta, Head of Customer Success Team for Pro Business Unit Arduino, and Brandon Canaday, Losant's Co-founder and Chief Product Officer. Before we hop in, I'd like to do some level setting around Losant and our enterprise IoT platform, especially for those of you on the call who are new to Losant. Losant is an application enablement platform, meaning we provide enterprises with the building blocks to create their own IoT applications. The platform itself consists of 5 key components to help customers achieve exactly that: edge compute, devices and data sources, data visualization, visual workflow engine, and end user experiences. Our customers and partners utilize these tools to create the robust IoT applications they put in front of their end users. And now a little bit about the Losant customer ecosystem. Losant is a leader in the industrial, telecommunications, and smart environment spaces, and we've offered this platform to a range of customers, including those in the Fortune 100. So, if you are interested in learning more, please reach out and we'd be happy to set up some time for a much more in-depth conversation. Just to set the stage a little bit, today we plan on talking about the powerful synergy represented by Arduino's high-performance and enterprise-ready boards and Losant's edge compute capabilities. Edge computing is a critical component for industrial manufacturers pursuing enterprise-connected products. Losant's edge compute makes it easy to interface with new or existing industrial controllers, tap into valuable streams of machine data, and solve customer problems. When combined with the powerful Portenta X8, it can drastically accelerate time to market for relevant use cases. And with that being said, I will now hand it off to Andrea to deep dive into all of these exciting possibilities.
That's great. Thanks a lot, Patrick. And thanks everyone for joining us today. So my name is Andrea Ricetta and I'm head of customer success team, as Patrick was saying. So I'm really pleased to be here today. And for my session, I will go through the Arduino Pro just to give you an idea of what Arduino Pro is. So we'll go through the product overview, some benefits, tech specs, and applications. So before anything, I will explain a little bit how Arduino is divided. So Arduino is composed basically in 3 business units. The one is the Arduino education that basically deals with schools, with students, with teachers, empowering students to learn by doing. The second one is the classical Arduino business unit. It's meant to for makers that basically provides creative solutions to everyday challenges. If you look for different projects on different channels, YouTube, and you will see a lot of projects made by users with Arduino boards. And the latest business unit introduced was the Pro. The Pro wants to enable business transformation It's basically a business unit that it has engineers, hardware, software engineers. So we're customer success, because the idea here is provide companies, so B2B enterprises, tools that are not only hardware but also software tooling libraries that are meant to be used for shrinking time to market, starting from development to production without the need of changing a platform. And this is the real powerful of solutions made by Arduino Pro. So basically, we want to transfer the productivity and creativity that for other markets in makers we started in 2005 with these makers, and now by transfer this knowledge that we learned in these 15 years more or less, we want to help the companies to transform the business model, help to moving ahead with IoTs, providing a robust IoT hardware, and of course support what is needed. So full development, production, and operational life cycle. By providing hardware, by providing firmware, low-code applications, compatibility with clouds, with our clouds, with third-party clouds, with partners' clouds, like in this case with Losant, and of course mobile apps. Before introducing the Portenta X8, a few words about Portenta family. Portenta family is a group of boards where Portenta H7 was the first one. That it basically has two best-in-class microcontroller in one. So it's a dual-core microcontroller. It has, for all the modules, it has Wi-Fi, so they are connected. Support high-level programming languages, meaning that apart from the standard Arduino language, we can support MicroPython, for example. We have a full development tools for programming the board directly in MicroPython. Every connected board or Arduino, starting from 2016 with the MKR boards, has security on board, meaning that every connected Arduino board is secure from the ground. So by providing all the tools that are needed for making a secure and robust applications, starting from the ground, from the hardware, and keep the data safe. High expandability. Every Arduino Portenta in the Portenta family has high-density connector that exposes more than 160 signals that can be used for expanding the capabilities of the board and connect daughter boards, custom carriers, or our solutions carriers and shields that can be used to expand the capabilities. Typical use cases, industrial machinery, laboratory equipment, and computer vision application due to this high computational power in a real density board. So let's talk about now about the Portenta X8, the queen on the hardware side of this session. So the Portenta X8 is a powerful industrial-grade system on module. It's a Linux machine with the dual approach of having on one side a Linux machine and Arduino board. So in the same, with the same hardware, with the same boards, you can leverage the best of these two worlds. So on one side, you can run your applications based on Linux. On the other side, you can run your usual Arduino sketches. On the technical standpoint, on the microprocessor side, we have an NXP IMX8 Mini. It's 4-ARM Cortex-A53. And on the microcontroller side, we have the same microcontroller that we have on the Portenta X7. So it's STM dual-core M7 and M4. The memories available on the RAM side, we have 2 GB of RAM and 16 GB of eMMC. It supports display port output from the USB-C connector. So you can plug an external monitor to have local HMIs. It has host and device operations. On the board itself, there's Wi-Fi and Bluetooth. Dimensions, it's roughly 6 by 2.5 centimeters. And then, of course, on the high density connector, we have the standard common interfaces that we can leverage to expand, the capabilities. So CAN, PCI Express, MIPI, SPI, I2C. So any kind of, I don't want to go to in technical, but it's plenty of opportunities there to connect different kind of signals. And one strong point regarding security, as I said, on the Portenta X8, we have the NXP crypto chip on a separate secure bus. So as you can see, it's a real powerful board in a really small form factor. So it's a system on module, right? So you can use it for a different kind of application. Just to name a few, in industrial automation, connected edge computer for manufacturing. So the X8 combined with the Max carrier, that it's a special carrier that we developed for using within the X8. With the X8, you can monitor sophisticated industrial equipment. You can take data, collect them, process on board on the edge, and send it to the cloud. And the Portenta X8 can be also a multi-protocol gateway. You can take the data, collect them, send to the cloud or a local ERP, leveraging different kind of radio transmission, Wi-Fi, LoRa, narrowband IoT, LTM, Cat-M1. So you can see there's a lot of opportunities. When it comes to AGVs or cobots or robotics application, by leveraging the approach of having this Linux operating system, and on top of that, we have a Docker container system. For example, having ROS, robot operating system, supported as a container, you can manage autonomous guided vehicles and control them locally. So any kind of components like camera, lidars, motor wheels, batteries, and so on. And of course, it can be also useful for managing, for example, trajectories for bringing goods from a point and to another on the plant. When it comes to building automation, managing offices and factories, of course, with these tech specs, you can deploy real-time machine learning and image processes right on the edge. You can use it for smart kiosk when by leveraging the display output port, Wi-Fi connectivity. You can remotely monitoring machine usage. You can, of course, deploy over-the-air updates, firmware updates, on container updates. So anything you can imagine on the OTA, you can do that. And when it comes to plant monitoring system, you can interact with HVAC, smart appliance, and execute on-demand tasks and advanced analytics just within this board. So for the Portenta X8, we developed some related product. Depending on the stage where you are, you can use it. The Portenta breakout board that basically, as the name says, breaks all the connectivity, all the signals, sorry, out from the X8, make it easy for testing purposes, testing sensors, connecting through USB different products or connecting to Ethernet. It has ESD cards, so can be used also for data logging applications. And of course, this is meant to be used into prototyping. That, of course, we release all the design. So if you need to go for a custom design, you can base your product starting from this. And then you can move to the custom, or for example, the Portenta Max carrier, it's packed, as you see, of different components. So here you can see radio different, it supports narrowband, Cat-M1, LoRa connectivity, it has audio part, it supports a mini PCI Express connector, so you can, if you have, for example, an external storage, if you have some kind of radio, if you have some, anything that can be used and support USB over PCI, mini PCI Express, you can use it right there. And on it supports also CAN bus, it supports USB. So this is a good starting point if you need something that it's more a finished product instead of pure prototyping tool. So here you can use how you can see the X8 fitting on the Portenta Max carrier, just as a reference. So few takeaways. I don't want to lose the time. So for the great demo, so few takeaways. With the Portenta X8, you have two industrial grade products in one, Linux and Arduino. On the Linux side, you have a Yocto distribution that it's already preloaded on the board, that it's ready to be used. You don't have to install anything. The board comes out with the pre-installed Yocto distribution. And on top of that, as I said, there's a Docker-based container system that it's usable out of the box. It supports popular programming languages, meaning that on in the containers you can have multiple programming languages. We do support out of the box Python, and we provide the containers or custom containers that already has Python that also can be used for managing communication between Linux and the Arduino part. You can deploy powerful AI algorithm and machine learning on the edge, and of course, last but not least, security. So leveraging the secure element that you have on the board, the Yocto distribution has a secure part that can be used for your applications. So just closing my session regarding support here at Arduino Pro, we have a full range of documentation starting from docs.arduino.cc, where you can find all the information. We have the community. If you need some training, we can set up a training for you. We have, of course, dedicated support, help center, and a lot of tutorial and example as for usual Arduino products. So my suggestion is to start from docs.arduino.cc, where you can find all the information. So I'm at the end, so thanks, and I will give back the stage for the demo. Thanks a lot.
Thank you, Andrea. That was a great overview. Let me share my screen. All right, well, hello, everyone. My name is Brandon Canaday. I'm the Chief Product Officer at Losant. And what I'm going to do for this deeper dive is kind of get our hands dirty. I'm going to do some interactive demos here, really showing how to initially set up an X8, how to use Docker, how to configure it for these Modbus serial devices, all the way to getting data onto a Losant dashboard. But what I wanted to set the stage with was a really popular use case, especially for Losant and in IoT in general, and that is equipment manufacturers converting the equipment that they make into smart connected products. And that kind of displays itself as something like this, some kind of interface where the manufacturer, their service partners, the end customer can come in, see real-time information about their device, maintenance schedules, ongoing health, whatever it might be for that specific use case. And manufacturers have a really nice advantage in that most of the equipment already has an existing controller. What I've got pictured here is a generator controller, but there might be a PLC or something on there that is already a source of extremely valuable information, which makes the upfront investment to tap into that data stream a lot easier. And in this case, I'm going to show how to use the Portenta X8 to talk to a Modbus RTU and TCP controller and extract that information. Now, Losant has a lot of functionality. I'm going to be focusing today mostly on our Edge Compute, which is a drag and drop workflow engine that we can remotely or deploy, design the workflows in the cloud and remotely deploy those to fielded devices. The X8's a great device here. For manufacturers, I want to introduce this. It's a SOM designed to be put on to custom PCB in a custom enclosure. I like that it has that enterprise grade robustness compared to something like a Raspberry Pi, where we've all seen the difficulties with the SD card based. Not going to give you that high performance and high reliability that you'll actually need, especially on fielded equipment with environmental conditions. So what's sitting next to me in my lab is this configuration. And this is what I'm going to be using to kind of just demonstrate how to initially get Modbus RTU data. This is what I'd recommend for anyone. Don't just jump right into your controller. Sometimes controllers are a little finicky. They've got a lot going on. It's really good to kind of start with something known. In this case, I've got this just off-the-shelf temperature and humidity sensor. It gets connected to this little Modbus RTU controller. That's wired to a serial to USB adapter, and then finally plugged into the Portenta breakout board through USB. That temperature humidity sensor you can get on Amazon for 20 bucks. Nice little thing to experiment with in your lab as a way to just get Modbus working before jumping into your actual controller. The breakout board I've got connected to my lab over Ethernet, and then the X8's attached to that. The X8 does have a really nice web-based setup environment, kind of unique from what I've seen on devices like this. You just plug it in your computer over USB. It actually presents itself as a network adapter. And then if you read the documentation, you'll have some pre-configured IP addresses. You just open your browser and you can just magically go to this IP address. And you get a nice web interface that onboards it onto Wi-Fi. But in this case, since we've got a whole lab here, I've got this, I'm using the Ethernet port going into my Edge lab where I've got other Modbus devices. That said, for Ethernet, always read the manual. I'm not going to lie and say that this didn't block me for quite a while, figuring out why the Ethernet wasn't working. Out of the box, that Portenta breakout board is configured for the H7, that embedded version of the Portenta. So if you read the manual, they do say you have to cut 2 jumper pads in order to make this work for the X8. So if you're looking at the breakout board right above the Ethernet port, there's these 2 pads. All you have to do is get like a razor blade and just scratch them apart. And then this will work for the X8. Just a little pro tip there, as I certainly spent a fair amount of time trying to get that work. And hopefully that saves you a little bit of time if you're doing this yourself. Next up is shell access. So whenever you get a Linux computer or a gateway, the very first thing you need is, well, how do I get a shell? I need a terminal access to it to start my configuration. And there are a couple of ways to get shell access. One is SSH, and that works if you're using the Wi-Fi setup. You can use the web-based thing, get it on Wi-Fi. You'll get the IP address, you can SSH into it. However, I'm using Ethernet. So I just plugged it in, and the X8 is configured for DHCP, which means the router assigns an IP address. So I don't know what the IP address is. So I have to somehow get into it, get a shell, and run ifconfig and get that IP address. So fortunately, out of the box, they run the Android Debug Bridge daemon. As Andrea said, it doesn't run Android, it just runs Linux, but that ADB daemon, it supports any Linux distribution. So you can go download just the Android SDK platform tools. You don't need the entire Android development environment, which is huge. This is just a small download. It's got a few of these binaries, and that's what you want to grab. Then once you've got that, you can run the command. If you run it with the devices parameter, after you plug in the Portenta to your laptop, wait a few seconds, you'll see it in the list, then just run the shell command and you're inside the Portenta. Then what I did, I just ran ifconfig to get the IP address that the Ethernet was assigned. This is usually when I would also set up a static IP address on our lab, but for this one, I'm still using the dynamically assigned one. Then from there, I can just run the SSH command, And this is in their documentation, but the username and password are both FIO. So if I switch to my terminal, and you can see it there, I'm running the SSH command, type in the password, and there I'm inside the Portenta, and now I can do all the rest of my configuration. So the last setup we need to talk about is serial access. On Linux, most, if not all Linux distributions, when you plug in a serial device, it's going to be mounted with only root permissions. And you don't really want your Edge software running under root just to get access to the serial device. That's a kind of a security problem. So there is a Linux subsystem called UDEV that controls what happens when these devices get plugged in. And in this case, when I plug in a serial device over USB, that USB to serial driver that's already built into Linux, it mounts those under TTY USB and then a number. The number increments with the number you have plugged in. In this case, I only have the one. And then what we're saying is, well, whenever one of those shows up, give it mode 0666, which is read and write access. This is the most permissive that I would recommend when you're going out into actual production. You'll know exactly what this is going to be. You may not need write permission, just read only permission, but this is a good way in a lab environment to get stuff up and running. And this file is written down to this location. That's the UDEV rules and this file. These are custom UDEV rules that you can add to this folder. The 99 is this kind of convention. These rules run in alphabetical order. So you'll see this a lot if you're looking at tutorials where you'll see just 99 dash. All we're doing here is making sure it runs at the end. If there's any built-in rules, we want them to run first. We want ours to just be alphabetically near the end. So if I go look back on my Portenta, I've already done this, but we can check out this file, rules. Yep, and there is the contents of my custom rule. So now if I unplug and plug in that USB port, it's going to run this and give it rewrite permissions for all users. There is a little more information on this on our blog. You can find this by Googling like Losant and Docker and serial. But we've got a nice blog article, goes through a lot of steps. And the first one there is a little bit more information about UDEV and what all that means. So, feel free to find this blog article for some more information there. All right, the next step is Docker. So as Andrea had mentioned, right out of the box, the Portenta, that Yocto image, it has Docker pre-installed. So that is a really nice addition. A lot of Edge software is now deployed as Docker containers. It's almost become de facto. So for Arduino to accept that and install that right out of the box, that's really nice. It's not something we have to set up, and our Edge agent does ship as Docker. So you can find our Edge agent on Docker Hub, Losant/Edge agent. I'm not going to go through a full Docker tutorial. That left to your own investigation and research, but I will talk about what specifically we had to do to launch this Docker container with to give it access to that serial device. So the first thing we have to do is pull the Docker image. In this case, it's this Losant Edge agent. I just pulled the latest tag. You will notice there are a couple of images that just come with the X8. There's a Python development environment that's there, and this is that actual web app. So when you sign into the web app and configure the Wi-Fi, that web app is actually hosted out of a Docker container. So there'll be a couple on there already. Mostly you can, if you're not using them, there's no problem keeping them there. So once the Edge agent is pulled, then you can launch it. And with Losant, I recommend using a config file. And I'll show the details of what these parameters mean in just a moment. But our Edge agent requires some device credentials in order to create that authenticated connection back to our MQTT broker. And that's how we push and receive all those workflows and all the device data. You give it the device ID, the access key, and the access secret. So I just put that in a folder here, Losant in my home directory, and I named it config.toml. Then if we switch to my README here, now I'm inside the Losant interface. The main overview page for Losant, you get this application README, great place to put notes, especially if you're collaborating with other developers. But right down here, I put my Docker run command. And this is what I ran to launch the Edge agent. Main things to keep in mind was I mounted the config file. So in that Losant, in the root Losant directory, there's that config file I just showed. This directory is documented by Losant, or this file. This is where our Edge agent inside the container will look for a config file. So I took a config file on the host and mounted it inside the container, and that's how our Edge agent knows how to connect and how to authenticate. And then right here's a really important one, -- device. By default, Linux containers have no access to actual devices. A serial device, any device you've plugged in, Docker won't have access to any of those unless you grant it access. So in this case, we are explicitly saying my container gets access to this device. And that is how we will eventually communicate with this Modbus serial device. Just telling it if it ever exits for any reason, restart always, and then launch that image. So this will take a few seconds to launch. We can verify its launch by using the Docker ps command. And we can see there it's running, created 6 days ago. Everything looks pretty good. So let's look at what we're going to build now that we've got the Edge agent running. We've given it that serial device. Now we can actually start talking Modbus RTU. What I'm showing here is a Losant dashboard, and I'm pulling information from this temperature and humidity sensor. And it's sitting right next to me on my desk. So we've got a couple gauges here, and we've got some about an hour or 2 days worth of information here, a data point every 60 minutes, all averaged together. So in order to get this data up into our platform so we can use our dashboarding tools, now we need to get into the actual edge computing. Now let's start with just looking at these devices. In Losant, there's a concept of devices. These are the virtual representation of physical objects. And I've got an edge compute device here. This is the device that represents the X8, that represents the gateway, the thing we're going to be deploying these workflows to. And really the most important thing here is just to assign it the device class of edge compute. We've got a lot of device classes. I'm not going to go into all of them, but edge compute tells the platform this device can accept workflows. We go back to devices, check out the temperature and humidity sensor. This is considered what we call a peripheral. And again, I'm not going to go into a lot of details here. The gateway peripheral model is an access control mechanism. So you can associate a peripheral device with a gateway. Let's pretend you've got 10 Modbus devices, 10 PLCs. You would represent each of those as a peripheral device, and you tie them back to the X8, because the X8 is the one that actually has the connection to our cloud. And this allows the X8 permission to report data, report telemetry data, receive commands on behalf of those peripherals. So Modbus serial device can't connect to the internet. So the gateway is kind of this intermediary. It's allowed to communicate on behalf of that device. So just an important concept to remember there. When it comes to devices, they are made up of tags and attributes. Tags are fixed or static information. In this case, I have tagged this with the serial device that it exists on the Linux box itself. And under attributes, this represents that telemetry data. So what we just showed on the dashboard, those all come from device attributes. Attributes have a name, a type, and then as that data is reported, Losant has that built-in time series database store all that. So now we've got the X8 configured, it's connected. We've got our peripheral data ready to receive some information. Let's build a workflow. So over here, you'll see the navigation kind of mirrors what Patrick started when he had that diagram of the Losant platform. We've got devices, data sources, data visualization, workflow engine, and then end user experiences where that final customer facing branded product gets built. But let's go to workflows. I'm just going to create a brand new workflow, and we're going to build this up straight from scratch, kind of show you how this is done. There are several types of workflows. Application experience run in the cloud, Edge runs on Linux gateways, and embedded runs on small constrained devices. Right now, we're going to do an Edge workflow. Edge workflows are tied to the version of the agent. We are constantly pushing new functionality to the Edge agent. So you have to know on the browser side which version of the Edge agent is deployed to the devices. And I know since I did latest, mine is 138, so I can use all the functionality that was added in 138. So you enter a workflow, you get a canvas, and now we can start building some logics. I'm just going to start with something very basic. I think a lot of viewers are fairly new to Losant on today, so I'm just going to make a virtual button and a debug node. We're just going to get something deployed and see what happens. This is a really good place to start. I always recommend incrementally building up your workflows, always checking the debug output. And let's go ahead and save and deploy that. When deploying a workflow, you can give it a version. We'll automatically create the current date as a version, but you could do 1.0 or whatever you might be there. When you deploy, you can choose an individual device, or what's more common, if we're talking about industrial equipment, we may have lots of devices that are all identical. And I just made a change to my Edge logic that I want to deploy into my entire fleet. So in this case, I can deploy to every device that has maybe this model number. So I've got workflows very specific to this family of equipment, and I can send it out to all of them. But in this case, I've just got the one on my desk, so I'm going to go ahead and deploy that. You can see it's very quick. It already gave me a check mark and showed me the live look icon just turned blue. So live look now opens up a debug connection directly to the fielded gateway all over the network. This can be anywhere in the world, connected over cellular, Ethernet. In my case, doesn't matter. From my desktop here, I can connect to it and see what's going on. And more powerful, I can click virtual buttons. I can click this virtual button. What that does is it sends a command all the way to the device, triggers this workflow. The device does whatever the workflow needed to do, it reports back. And now we see I got my payload. And since there's really nothing going on, all we got was the default information that every payload starts with. So got information about my device. I'm running on this X8, so I got all my metadata there, but nothing really else. Concept of a workflow is they all start from green nodes. They'll flow through all the nodes and they operate on this payload. Maybe they send the data somewhere else, make some decisions on it. In this case, we're going to eventually add Modbus data to this workflow and report it up. Let's make some changes, and now let's read some Modbus. So Losant has lots of southbound or industrial connectors. We've got Allen Bradley, BACnet, there's Modbus, a lot of OPC UA stuff, and then a ton of connectors to other cloud services. Nice little help. Oops, I don't want a file, right? No, you can read and write local files too. Let's do the Modbus read, put that in there. And now we're going to use this information, TTY, USB 0. We can confirm that. We go back to my terminal. Let's confirm that that's actually connected. And we can see it right here, TTY USB 0. So that's what I am putting here, /dev. All this other information comes from the specifics of this controller. This one happens to use the default, but you'll need to refer to your controller's documentation for this. And you'll also need to refer to your documentation for the actual Modbus registers to read. I'm not going to go into a lot of details about Modbus in this presentation, but the high levels are really you're reading registers at some address. And every result you get is a 16-bit signed or unsigned integer. And based on the documentation from this sensor, I happen to know that temperature is in address 0 and humidity is in address 1. So I can read both of those at one time by starting at 0 and reading 2. You can add as many read operations as you want. In this case, I'm just doing 1, but you might have a lot of registers you read, and you'll build up a big object here. We'll show in a moment. And I'll put that back on the payload. So I can save that, deploy, back to the X8. See, it's already done, it's very fast. Go to live look, click that again, and working Modbus values. So if we open this, we can see I read 2 values. I put them on the key value, and then I added that result to working.modbus. So you can see there's working Modbus there's the value that I tagged here. What would happen is if you did multiple read operations, you get multiple property values here. And then there's my two values. So the first thing you might look at is, well, if it is 219 degrees in the office, it's probably pretty uncomfortable. But as I mentioned before, Modbus values can only come back as 16-bit signed or unsigned integers. So a lot of controllers get creative in how they pack information. In this case, they multiply these values by 10. So you can get one decimal point of resolution. So let's go back and divide these all by 10 to get actual values. So in Losant, we'll just add a math node. And if we bring up in the debug panel again, expand that most recent entry, the debug panel is invaluable. It's always should be open when you're developing workflows. So what I want to do is take this first one, and you can right mouse click on a value. So right down here, I'm here. If you right mouse click on this, you can copy that path. And in Losant, we use this templating language. It's actually handlebar templates, but things in double curly braces will reference this location. So working Modbus value and then dot and then the index gives me working Modbus value and then the index. And I need to divide it by 10. And we'll just say working dot temperature. And we'll do the same thing, except I'm going to change the 0 to a 1, and that is humidity. Okay, let's go ahead and save and deploy that. So you can see how fast it is to iterate on your development, get this information, or make changes to these workflows, and also get those workflows out into the field. So let's click that button, see what we got. We got a new result, working. Oh, we got temperature, but no humidity, so something's wrong. And also, I like this. I'm getting some wonky information, and I tested this earlier, and my controller is just acting up right now. And I could have swapped it or power cycled it, but I actually wanted to leave this. This is a really valuable lesson. You'd be surprised at how brittle actual controllers can be. So we've seen a lot of cases, production engine controller, it's been fielded forever. And we start trying to read it. If you read it too fast or just the wrong way, you can actually crash the whole controller. So what we'll have to do is add some checks for this, but I left it in there because, especially in Modbus RTU and some of these and TCP controllers, you'll get some strange behavior, and this is a really important time to test that. First, let's see why I didn't get humidity. I should have. Well, let's just deploy, and let's click that a few times. See if we get an actual value here. No, still only got temperature. Well, I got a good one there. So 21 degrees Celsius. Oh, I put it at, that's why. I put it at the root humidity. So it would be, it is right here. I forgot to put it under working. And working is just a best practice we've adopted. I like to keep the starting payload original. I don't like to add or modify anything on the root payload. I usually typically use this working object for the new data. So cool. Now we've got some good data. Let's add, well, let's go ahead and confirm that. That's how quick it is to deploy a bug fix. There we go. So there's our raw values divided by 10. There's humidity and temperature. So we saw some strange results. Let's go ahead and do a check and filter those out. If we do get some strange readings, we just want to just skip this one. The sensor just returned some invalid data that time. So let's go ahead and do a little check here. We'll say, we'll just make sure working humidity is, well, humidity can never be 0 or never be less than 0. So we'll make sure humidity is always greater than or equal 0, and temperatures can go negative. We'll just say they're greater than, negative 100. Looks like when it gave me some strange values, they were negative like 300 degrees. So we'll just make sure the temperature is above, some reasonable number, and the humidity is also above a valid number. So the conditional branch in this case, we'll just go ahead and attach both to that. Make sure we're still getting data that we want. Here, everything's looking good. We got some good data. Okay. So now if we got valid data, now we actually want to report that information up to the platform. That's called device state. So in device state, we're going to go ahead and just choose that temperature humidity sensor. And we've got our two values. So if we expand the debug entry again, we want humidity and we want temperature. And then we'll just connect the rest like this. So there we are. At this point, if we deploy this, when I click this button, we should be reporting information up to the cloud. And when you mouse over debug entry, you see my mouse is over here. It does highlight the path that the workflow took. So if you look back over here, you can see this line is gray, so it didn't take this path. So we got validated, took this path to get to that debug node. So it can be really helpful to figuring out, which path the workflow took. So let's go ahead and confirm this really quick. Let's go back to the device here, temperature humidity sensor. Actually, let's just go ahead and click that button again, and we should see in our live log here, state come through. In almost every place in Losant, there are live logs, very helpful in initial development and debugging. So let's go ahead and click that again. We just saw that come through. And there we are. So in the live log, and you can see some of this gateway peripheral model here. We're saying the Portenta X8, which is the gateway, it reported the state of this peripheral. So the peripheral didn't report its own state. It was reported on behalf of, or the gateway reported on its behalf. So there's the humidity and temperature. We can go to the attributes tab and we can see the most recent value matches those reported at that date. And we're looking good here. So the last thing I want to do is, clicking a button is nice, but not particularly useful in a real world scenario. We need this workflow to trigger by itself, kind of on an interval. The most common thing we see when capturing controller information is on a timer every hour, every couple of minutes. It doesn't really matter. It's use case dependent, but in this case, we can do that with this timer trigger down here. So we can just grab a timer, put it over there. And now instead of clicking the button, I can say, well, go ahead and just read this every 10 seconds. Go ahead and save, deploy that. And view the live look. And I'm going to go ahead and while this is kind of capturing some data, I'm going to breathe on this sensor a little bit. We're going to get our humidity up a little bit so we can see that this is actually working. There we go. We just got a new one. I can pause the debug. Yep, their humidity way up to almost 50%. So we're seeing some real data come through, and we can confirm all that back on this device. Yep, there's those reports. You can see we started 28. I started breathing on it. We went to 49, 56. Okay, so that's nice. We've got this is the information required for this dashboard, the temperature, humidity. Now we're collecting snapshots of it. We can make these time series graph. Let's do some alerting. And that is this workflow here. And what I want to do is make an alert whenever that humidity exceeds 40%. And I can do this with something called a latch node. And what I'm looking at here is actually a cloud workflow. So workflows, certain actions in Losant can trigger other workflows. In this case, I'm reporting device state, and we've got a device state trigger. So whenever that peripheral reports state, I don't have to put everything in one giant workflow. I can trigger some other workflow to trigger whenever that happens. It makes the workflows very clean, very functional. And in this case, I'm triggering whenever temperature humidity sensor reports state. And it's going through a latch node. Latch nodes is really nice. They kind of latch open, latch close, however you want to think about it. If the humidity does get above 40%, we don't want to just keep getting events and alerts every time it's still there. We're reporting every 10 seconds right now. We're getting an alert every 10 seconds. So what the latch node does is it will allow the path to go through once when the condition is met. and then it won't allow it again until there's some reset condition. So in this case, if the humidity goes above 40, I'll get one event, and then it won't trigger again until it goes back under 40 and then back over 40 again. So just a really nice pro tip there to look at the latch node if you're getting a bunch of duplicate events. And we're using the event create node. Losant does have a concept of events. And in this case, I'm just filling in some information about it. You know, a lot of manufacturing environments are very sensitive to humidity. So I'm considering this a critical event. Nice little message here. You can associate events directly to their devices that cause them. And then on the UI, we can go over here and see all the events that has occurred. So when I was breathing on it just then, we likely got another event. And we can click on these, we see all the information, we see the device associated with, and then, you know, your users or operators, service techs, whoever can come in here and say, you know, oh yeah, it's resolved. We opened, you know, the garage doors and let some air in or something like that. You know, not a major deal. We resolved. We know what was going on. And that's really what I wanted to cover here. You know, the core of this was really getting that Arduino X8 up and running. A lot of times that's one of the most challenging points is just getting that online first, getting the Docker container installed. And really, ultimately, you know, we're leading up to, you know, something like this. We've got all these devices in the world. All of them are reporting all this information. And this portal here is represented through, the last tidbit here is the Losant experiences, where this is an entire web building environment where you can build these applications entirely multi-tenant, fully authenticated. You know, this is where that final end product takes form, something like this. And with that, I'm going to hand it back to Patrick. Patrick.
A couple more call outs I'd like to make here. First and foremost, we want your feedback. Your experience working within our platform means a lot to us and to other developers. So we hope you'll help us spread the good word about the power of the Losant platform on review sites like Capterra or G2. Next, we'd like to call your attention to a couple of exciting events we have coming up soon. On April 27th, we'd love for you to visit Losant's virtual booth at the Kasambi Summit. We're also delighted to share that Charlie Key, co-founder and CEO of Losant, will be talking about the Internet of Things and how it is being used to empower the freedom to create a brighter, sustainable, and more profitable future. Additionally, we'd like to invite you to join both Losant and two of our partners, Charlton Morris and Particle, on May 10th for another exciting webinar on sustainability and the intersection of IoT and ESG. You can navigate to either of the links on your screen to register. And now for a few additional resources. For further learning, the Losant documentation space is a great place to go. Visit the URL you see on the far left. For more of an interactive education, Losant University's combination of video training, hands-on workshops, and assessments provides the fastest way possible to gain an understanding of the Losant Enterprise IoT platform. To see specific hands-on tutorials, visit the second URL from the right. And last but not least, if you have a question, somebody else might have already asked it. Visit Losant's forums to check yourself or just to jump into the conversation. That being said, let's go ahead and dive into those questions. First question is from Sunand, and it is, how does Portenta compare with Raspberry Pi in terms of performance and price?
I think that it's for me.
I think so too.
And so yeah, basically it's a different starting point. We developed the X8 with the aim of bringing the same Arduino experience plus the capabilities of having a Linux machine on board. So it's a really mixed product with all the security, with all the different application that can be used with the Portenta X8. So I would say that it's not fair to compare, but just because they are different products. In terms of performance, we have more or less on the Linux side the same. On the microcontroller side, of course, we have this additional dual-core microcontroller. In terms of price, again, it's intended to be used as an industrial system and module, so it's more than cost rather than pure cost. It's probably more fair to say that in terms of cost efficient. The X8 brings a lot of power, of course, with a little pricey in terms of standard economic from a standard economic point of view. I hope that I replied to your question.
Great. Thank you, Andrea. Another question from Jeremy. Do you have the ability to build test workflows using something like virtual sensors or devices, or would you need to replicate the behavior needed for development locally or live, like in the demo?
Yeah, I'll take that one. Yeah, it's really common to use virtual devices or simulated devices. And actually one of our, actually the very first walkthrough you'll see if you sign up for Losant, I totally forgot to mention, everything I showed can be done for free in Losant's developer sandbox. So when you sign up for that, there will be like a weather dashboard walkthrough. We're actually querying weather data from a free API and recording that onto a device. So it's a really good way to experiment with workflows and dashboards without requiring physical hardware. There is also an asset tracker template that demonstrates how to use workflows to actually replay or simulate data back into devices, and as well as the Ellipsa predictive maintenance template that's actually replaying real turbofan telemetry data from a NASA data set. So it's really common to simulate device data. There is actually a simulator tab in all the devices pages as well. So yeah, you don't need actual physical hardware if you want to get in there and play with workflows. There's a lot of ways to simulate or create those virtual devices.
Great, thank you. Okay, next question. How many Modbus devices can be connected to one X8?
Yeah, I'll start with that, and Andrea might have a follow-up, but there's a couple of different ways to think about that. One, of course, is if you're doing like TCP, the number can be quite high. It's just how many are on your network and accessible. And it's also a variable on what those workflows are doing when it receives data. You've got very expensive workflows using a lot of processing power. Maybe you're running, I've done some fun tests where I have run a local object detection algorithm taking camera data in. So if you're doing something expensive like that, the number's going to be a little smaller. But a computer as powerful as the Pro, I would see easily, hundreds of devices. In the scenario I saw, we're just pulling, a few attributes every few seconds. You could easily get into the hundreds. RTU serial is kind of based on the hardware side. So that's going to be a little more limited, maybe just a handful of that. But I don't know if Andrea has any clarifications on that.
I think that you explain quite clearly. Yeah, the scenario is that. So on the TCP side, of course, due to the different paradigm of connectivity, I think that it's more capable of running multiple devices. While on RTU, it's more limited. So yeah, that's perfect.
Great, thank you. Next question. Is the container engine compatible with third-party containers? Additionally, which languages are supported?
Well, yeah, the container engine is a standard Docker container. So it's Brandon was showing, he was just pulling from a standard repo on Docker. So yeah, any container that it's basically works should be must be compiled for ARM64. It's the platform. And yeah, apart from that, let's say that the standard container, like, I don't know, any kind of programming language or database, or you can run different kind of database right on the board. So yeah, it's compatible. And regarding languages, again, if you can download a container that works on ARM64, it's compiled by ARM64, you can have multiple languages. There's no limitation on that. We do provide support out of the box for Python, just to give another information. So we support out of the box the Python environment.
Great.
Yeah,
Thank you.
the Losant Edge agent is written in Node, and it uses the standard Node containers to run our Edge agent in. So that's just a data point. If anyone's thinking about using Node.js, that works just fine.
Okay, thank you both. We just have a couple more questions here. How much storage do I need for the Losant Gateway Edge agent?
Yeah, I can answer that one. So we ship 2 versions of the Edge agent. One uses what's called an Alpine image, which is a lot smaller, and that uses a few hundred megabytes of disk storage. The full Edge agent, which runs on the regular old Node.js base image, takes a little over a gigabyte of disk space. The trade-offs there are, if you're just using the Edge agent out of the box, the Alpine is a really good fit. The full container has a little bit more of kind of the Debian userland tools inside it. So if you need to jump into the container and do any kind of debugging, or if you want to extend that container with your own scripts, got Python already installed. It's very common to bring Python scripts, extend our container with your own custom Python scripts, and then you can actually invoke those with the workflow engine. But it has Python installed. It's got quite a bit more tools installed into it, a little easier starting point. So yeah, a couple hundred megs, few hundred megs, maybe 300 or so for the Alpine, and a little over a gigabyte for the full container. That's disk space. When it comes to memory, again, that's really variable in what your workflows are doing, but as little as 20 megabytes up to a couple hundred megs of memory.
Great. Thank you, Brandon. And now for our final question. Are there any options for installing the Losant Gateway Edge agent on a lower constrained device that does not support containers?
Oh yeah, so that would get into our embedded Edge agent. Relatively new launch. We are investigating support for that on the H7. I am pretty positive that that's going to work. Just keep an eye out. We've got a repository of examples there. So the embedded Edge agent actually compiles the workflows down into self-contained WebAssembly. And then you can use, there's a couple of options available, very portable WebAssembly environments that don't require any operating system. We've got a great example for the ESP32 line and FreeRTOS. Check out the embedded Edge agent. It's far less capable, obviously, than the full Gateway Edge agent, but it can be a really big productivity boost if you're on those smaller constrained devices. Those I recommend about 2 megabytes of memory. So not those super tiny devices, but kind of a more meaty embedded device.
Great. Thank you, Brandon. And I know we're over time right now, but we have a great question from the audience. So we're going to do one more from Eric. Could you provide insight on how much time is saved by an industrial OEM by choosing the Portenta series versus alternative approaches, such as custom design, gateways, etc., including gains in time, money, and lower risks to the program in question?
Well, that's a really good question. So, I think that I will try to summarize the most interesting stuff. Well, of course, when it comes to alternative approach such as custom design, well, if you adopt a Portenta series board, you don't have to go into custom design. And of course, by having those kind of signals, probably the only custom part that you can do or you need to do is to just design the daughter boards or the expansion board, because everything and on the other side is ready to be used. And this just to give some time in terms of time to market means that at least 6 months of development on a custom design, it's shrinked. In terms of cost, custom design has some NREs. It has a cost for prototyping, validating, iterating, and certify the board. So again, there are no fixed costs, of course, but depending on the project, if you have to start and build something that it's around the specification, the technical specification of the X8, I would say that something around 100,000 dollars at least for NREs. And by choosing the X8, you can cut them because you will find something ready to be used. And then again, on the software side, also having an operating system that it's already deployed. You don't have to manage all the engineering part for deploying a custom Yocto distribution on the board. And by leveraging the containers, you are up to ready to go to connect for example, on the cloud side, Losant. And so in that case, you are really easy. It's really easy to go and start iterating the business ideas. So the main advantages when it comes to TCO, so total cost of ownership, that it's mainly the driver here. You can save a lot of money and time by leveraging on existing system on module like the Portenta X8. And then depending on the system on module, in Arduino, we want to, to be flexible. We don't want to tie people. We are customers. We are flexible and open. And this combination of the X8 with the Losant cloud, it's a perfect example. So you can run in, I don't know, Brandon, how long you take to make it work, but I think that it will be, a week or something like that. So a week for running, a complete example that could be a business project. I think that it's a good example. I don't know if you want to add something on your experience, Brandon.
Yeah, definitely. So when we get to, the OEMs, and again, I'm really talking about fielded equipment, the volumes are quite high, as little as 1,000, mostly into the tens of thousands. And most of our customers in that area do start with off-the-shelf gateways and with cellular connectivity most commonly. And those are quite expensive, especially when you get to ones that are industrial, that got the ratings. When you get an off-the-shelf gateway, add a cellular modem to it, it's very difficult to get those under $500 each. So what we typically see is they'll start with that. It's a really good way to get into market incredibly quickly. Then they'll start figuring out, okay, when we get to scale, we can save a lot of cost by, Andrea, just what you had said. Let's pick a SOM. Let's make our own breakout board. Let's integrate it basically into the equipment itself, kind of an engineering rev. Instead of retrofit gateway, let's just integrate it more into the equipment itself. So then I like the Arduino line for all the reasons you said. The Yocto image, a little more modern than what we've seen in a lot of others. It works with the Docker right out of the box, which is great. And then you maintain that, easy to update it. And then, of course, from education standpoint, it's hard to beat Arduino. Portenta or the Pro line's a little newer, so that community is still young and growing. But I find usually, especially on the maker side, if you Google any question, the community has solved that for you, which can really reduce the cost of getting the initial development done. So that's how I see it. Time to market is going to be quicker with an off-the-shelf gateway, but you're going to have a lot more expense. And then what you do, kind of that phase 2, start integrating that into the equipment itself, lowers the unit economics. Using something like a Portenta, it's just going to get that engineering effort done a little bit quicker.
Fantastic. What a great question to end on. So thank you to everyone for your great questions, and to Andrea and Brandon for helping us through this discussion. With that, we will go ahead and wrap up. Please be sure to connect with Losant or Andrea and Arduino via the contact information and web URLs on your screen. Thank you for your time, and be sure to have a great afternoon.